Hello guys, welcome back to my channel. This is Varun. In the previous lecture, we have seen how to use Numpy library for computing large data sets by creating matrices and also some methods of scientific computation using Numpy linear algebra functions. Okay, so if you guys have not gone through it already, I would recommend to check that video first in order to understand the concepts taught in this lecture. Now today we are going to talk about Pandas library. Okay, so Panda is a library built using Numpy specifically for data analysis, and it is a Python package providing fast and flexible and expressive data structures designed basically to make working with relational or labeled data both in easy and intuitive manner. Okay, and we will be using Panda heavily for data manipulation, visualization, and building machine learning models, etc. Okay, so Pandas aims at becoming the most powerful and flexible open data analysis and manipulation tool available in the market. So Pandas is compatible and is made to work with different kinds of data sets. Okay, so some of the examples we can state as tabular data with heterogeneously typed columns, example of which is an SQL table or Excel spreadsheet. Ordered and unordered data which may or may not necessarily be of fixed frequency, example of which is time series data. Then arbitrary matrix data which can be either homogeneously typed or heterogeneous data with rows and columns as labeled. Then any other form of observation or statistical data sets, and there is no other prerequisites and the data need not be labeled at all to be placed into Panda data structure. So that is the main advantage of using Pandas. Now there are two main data structures in Pandas, namely series and data frames. The default way to store data is data frames, and thus manipulating data frames quickly is probably the most important skill set for any data analyst, and thus this session is very important for us to step into data analysis domain. Okay, so I will give you the source for Panda documentation in the description, okay, so that you can go through. And now in this session we will be studying the Panda series similar to the Numpy array we have seen earlier. Okay, how to create the Panda series and indexing the series, and then we will see the creation of data frame from dictionaries, and then importing the CSV data files, and then reading and sorting the data frames. Now let's look at Panda series. So a series is similar to 1D NumPy array and can contain scalar values of the same type. Okay, examples you can define as numeric characters, date time, etc. Okay, and a data frame is simply a table where each column is a Pandas series. Okay, so combination of Pandas series can make up data frame. Okay, so the main difference between series and NumPy array, guys, are that series often contain non-numeric data. Those can be characters, dates, times, booleans, etc., while NumPy array contain only numeric. Okay, so now we can create Panda series from array like objects using pd.series. So let's check out that. So first we have to install Pandas in our system. Okay, so for that you need to open command prompt. Okay, so just type command prompt, or you can type cmd also in your system if you own Windows. Then here you have to do a pip3 or a pip install. You have pip or pip3, depends on that which command runs on your system. So I have pip3, so I'll do pip3 install pandas. Okay, so you guys can see it is already installed in my system, so it is prompting that I already have these dependencies. So now I'm free to use pandas. Okay, so I'll say import pandas as pd. Okay, and I will use numpy also, so I'll use import numpy as np. Okay, now let's create a series and show you guys how it is done. So pd dot series, and then we will give a list inside it. 2, 3, 4, 5. Okay, and I will print this, and then I'll print the type also. Okay, so it has printed the series now. You can see the indexes come here and the actual data comes here, the second column. Okay, so it is in int64, data type of it, it's homogeneous, and it is of type pandas core series. Now let's see how we create a series of characters and date time. Okay, so I will say char series. Okay, and I'll do pd dot series and give list of characters here. So a comma ab comma c. Okay, and now I will print it. So you guys can see here it has created a series of characters and the d type is object here. Okay, now let's check out how do we create a date range using pandas. Okay, so if we want to create a series of date ranges, we can easily do that via pandas. Okay, so we'll say date underscore series equals to pd dot date underscore range. Okay, so I'll give a start date, so this is the parameter it expects, and I will say for June 01 2021. Okay, so format here is mmdd and yyyy. Okay, and then I will give end as 10th of June. So end, and this is 10. Okay, so it has created the date ranges starting from 1st June till 10th June, and you can see the d type as date time ns. So let's check the type of it. So I'll say print of this type. So you guys can see here it is of panda.core.indexes datetime index. Okay, so we can do this via various methods also, like only specifying the periods and the start date. So let's check that also. Let's say that I have the same object here, and instead of taking end as input, I will do periods equals to 10, and I'll print it again. Okay, so you guys can see here it has started from 1 and it has taken 10 dates, incrementing one by one. Okay, so giving the exact same output. Okay, so you guys can see here the frequency default is days. Okay, so it is incrementing by per day basis. So we can have this for per month basis also. So for that, what we'll do is we'll change the frequency to m, that is month. Okay, and then we will print this. Okay, so what it will do is it will start from the end of the month, that is current month, that is 30th of June, and it will start incrementing per month basis. Okay, so this is June, July, August. So like that you will have the frequency, that is 10 dates are returned. Now let's see if we want to skip some months and still want the date ranges to work, then how do we do that? Okay, so I'll have the same thing, and then instead of this frequency as m, what I will say is pd dot offsets dot month end. Okay, and then I will give 3. So I have to skip 3 months every time and print the dates. So let's check this out. Okay, so this gives 0609, so that is the June, and then September, and then December. So it is skipping every 3 months and it is printing the dates till 10 dates are returned. So periods are 10. Okay, now if we want to change the time zone, we can still do that. So date range gives us the flexibility to specify the time zone as well. So I'll say time zone as Asia / Seoul, and let's say that I want only 2 dates. Okay, let me print this out. So exactly it has changed the time zone, and you can see here the difference. Okay, now let's check how to get elements from the series. So I'll say pd.series, just to create one more. So I'll say 3, 4, 5, 6, 7, 8, 9. Okay, now I'll print this. Let's say that we want to have the element which is 4th element present at the 3rd index. Okay, so we'll simply say S3. So you guys can see in the 3rd index 6 is present and it is returned. So it just behaves like an array here. Okay, but it gives us more flexibility than any other array. So let's see what all flexibility it has. So let's say that I want to have all the elements starting from 2nd index till the last. Okay, so starting from 5, it will return all the indexes here. This was also present in the array. Okay, now the extra thing that it gives is we can still have the individual indexes returned. Okay, so let's say that I want to have data which is present in index 1 and 3. So I can still do that, and what I have to do is I will include 1, 3 as a list and pass it in this series. So you guys can see here at 1 index 4 was present and at 3 index 6 was present. So both of them were returned. So there is one thing to mention here. The input to this will always be a list when 2 indexes are to be used. Okay, otherwise it will never work. So you guys might have noticed that while creating a series, Pandas automatically indexes it from 0 to n-1. If I show it here, so you guys can see here, it automatically indexes it starting from 0 to n-1. But if we want, we can also explicitly set the index ourselves, okay, using the index argument while creating the series. So let's check out how it is done. So I will create one more series here, say pd.series, and have 0, 1, 2 as data points and index argument with a, b, c. Okay, and then I will print this. Okay, so you guys can see now the indexes has changed to a, b and c instead of 0, 1, 2. Now you can also give the indexes as a sequence or use function to specify the indexes. Okay, but we have to always make sure that number of elements in the index list is equal to number of elements specified in the series. Okay, by this what I mean is, if I create pd.series, okay, with some elements in it, let me use np.array for it with a range function here having elements starting from 0 to 10 and squaring those elements. So it will have all the numbers starting from 0 to 9 in squared form. Okay, and I will specify the index as range 0, 10. Okay, if I print it, you will see here that it has all the numbers in squared form starting from 0 to 9, and it has also printed its indexes. Okay, if I want to change this, I can still do it. Let's say that I want to start the index from 1. So guys, please remember the index length should always be equal to the data length here. So I will increment both the ways. Okay, so now it is starting from 1 and ranging up to 10 indexes. Okay guys, now let's move on to Pandas data frame. So data frame is most widely used data structures in data analysis. It is a table with rows and columns, with rows having index and columns having meaningful names. Okay, so there are various ways of creating the data frame, such as creating from dictionaries, JSON objects, reading from text files, CSV files, etc. So I will be showing now how to create a data frame from dictionaries. Okay, so let's create a data frame named as df. I'll say pd dot data frame. Okay, and then I will mention keys of dictionary, name, and then having values as list. Let's name them as Vinay, Kushal. Okay, and then I will give their ages. Let's say their ages are 22, 24. Okay, now let's print this. So you'll see here it will come like a table here with indexes in the left column and name and age as the columns and their values in different rows. Okay guys, now let's see how do we import CSV data files as Pandas data frame. So for the upcoming exercises, we will use this data set of a retail store having details about order place, customers, products details, sales and profit, etc. So for that, I have created a GitHub repository where I have uploaded that data set for now. So I will give the link in the description for you guys to download. So I'll just click it here. So once you click it, it will automatically open this GitHub repository where I have uploaded this global sales data zip. Okay. So what we have to do is we have to go here and download it. Okay. Now we will open this show in folder and we will copy this. Okay, now I have to go to where my notebook is running. So guys, my notebook is present here, so I am pasting the zip here in the same location. So what I'll do is I will right click it and I will extract it here. Okay, now this folder will contain all the CSV file which are present in that repository. So guys, you will be seeing the same files here and we will be able to access that using our notebook. Okay guys, now let's load that CSV here and read it in a data frame. Okay, so for that I'll say market df and do pd dot read underscore CSV, and inside I have to give the path of that CSV. So guys, you remember it is under global sales data and market underscore fact. Okay, so I will say global sales data slash market underscore fact dot CSV. Okay, and I will print this. So for getting few of the initial rows of this data frame, we will use head method. Okay, and I will execute it now. Okay, so you see here that it has all the columns and rows. Okay, and now let's tally those with the CSV. So what I'll do is I'll just open it. Okay, so it has all the columns in the first row and starting from the second row it has the data fields. Okay, so it has almost fetched 5 rows from here. So until row 6 you can see the data is present. So after we have imported a data frame, we would want to quickly understand its structure and see some of its method. Okay, so further we will look at the summary statistics also, like means and percentiles, etc. So let's check them one by one. So just like head, there is a tail method also which the data frame provides here. So we'll say tail. Okay, so it has returned last 5 rows of that CSV. You can tally also. So the second last is order 5348 and the last is 5459. So exactly 5348 and 5459. So now we can also check the information of this market DF. So there is an info method that we can use here. Okay, so you'll have all such details here, that what is its type and what are the range indexes and what all data types it is having. Okay, and what is the D types of it and what is the memory usage of it. Okay, so note that each of the column is basically a Pandas series, okay, of length 8399 here, as it has specified. Okay, the ID columns are objects, so they are always being read as a character. Okay, and the rest are numeric fields. You can see here float and integers. Now we'll see the describe method, okay, and what it means. So we'll use describe here. Okay, so it will show you all the statistics of various columns. So it will give a summary of all the numeric columns in the data set, and you can see here it has given for count, mean, standard deviation, the minimum, and 25, 50 and 75 percentiles from that column, and maximum. It describes the distribution of our data. 50 should be a value that describes the middle of the data, and 25 and 75 is the border of the upper and lower quarter of the data. Okay, and we can get an idea of how skew our data is. So note that here the mean is higher than the median, which means that our data is right skewed. So please note guys that by skewness we mean that more the data is towards either the left or the right, it is more skewed. That is, more data is present on that side. So this is, you can say, as right skewed data, as mean is greater than the median. Okay. So if the mean is less than the median, it will be a left skewed. Either ways you can consider. So we'll look at these concepts of statistics later in our section, where we will be digging deep into the each concepts of statistics. Okay, let's move on now. So let's say that I want to check what are the columns here. So I will simply say columns. Okay, so it will be in a list format here. Then let's check out the shape of it. So I will say dot shape. So you guys must be familiar with these terms now, because you have used those numerous number of times in arrays also and in Numpy arrays also. Okay, so it is having 8399 rows and 10 columns. Okay, now let's check out its values. So there is a values method here. Okay, so it will be a form of an array here. So an important concept in Pandas data frame is that of row indices. Okay, so by default each row is assigned indices starting from 0 and are represented at the left of the data frame. Okay, so we have seen this previously also. When we call head of this data frame, you will see all the indices present at the left of the data frame starting from 0 and incremented by 1. So it is not necessary always that we keep this as the default. We can also change it. So in cases where we know that, okay, one column we have and that is having unique data in all of the rows. So we can make that as a primary key sort of thing, like in SQL. So we can make that as an index instead. Okay. So we may want to change the index of that data frame to something more meaningful, which is this order ID. That will be unique, and so that we can select rows using the order IDs directly. So that can be done using market df dot set underscore index, and we need to give the column name for which we need to set the index, and I will say in place equals to true. That is, I am specifying that I want to make this as the index, so it will not come anymore as a column, but it will start coming here at the left of that data frame. Okay, so you guys can see here it is no more coming like a column, but it is more of like an index now, and we can still query it. So guys, let me tell you an advantages of having these sort of custom indexes. Okay, so having meaningful row labels like these indexes will help us to select the subset of data frames easily. Okay, so we will study selection of those data frames in the next section. Now let's move on to sorting. We can sort data frames in two ways. That is, first via the indices and second via the values. So let's check the index one first. So I will take the same data frame here and I will do sort underscore index. Okay, and I will specify the axis equals to 0 and ascending equals to false. Okay, so axis 0 here means that it indicates that we want to sort with the rows, and if we give here 1, then it means that it is for the column. So this is an index sort. Okay, and we are using ascending equals to false, that is we are using descending as the sorting mechanism here. So let's check. Okay, so exactly it has sorted it in descending order. So guys, please note here that these are considered as string. Okay, so if you place here any numeric value, it will be in exact descending order. So here you will see that it is considering the first digits and second digits and third digits with the subsequent other strings. Okay, so here 999 is the highest, and then comes the precedence for 10 and then at last for ones. So this is sorted in descending order now. So guys, in simpler terms, the order ID is converted to ASCII values and then it is sorted in descending order here. So that is the reason for this kind of output. Okay, so now we will see sorting by values. So we will use market df dot sort underscore values, and then we will place a column here. Okay, so we'll say sales. Okay, and then we will take the head. So it will sort all the data frame rows via the sales column, and you can see here it has sorted via the increasing order, which is ascending order, which is default. Now let's sort this data frame via some other column. Let's say shipping cost. Okay, so I will take this again and change the column name to shipping cost, and let's say that we want a descending order sort. So I will say this ascending equals to false. Okay, so when we look at this, we will see that it has sorted it in descending order. So let's say that we want to sort the data frame by more than one column. So let's check that out. Okay, so we'll have this again, and then what we'll do is we will give here a list instead of a single value of a column. So let's pick two columns from here. Let's say product ID is one of the column and second is sales. Okay, So you guys can see here, you will see a single product ID. Okay, so there are multiple sales record for a single product, and you will be seeing the sales record as decreasing order. So both of the columns it has considered, and then it has sorted the data frame in descending order. So this brings us to the end of the today's session, guys. In the next lecture, we will go more deeper into individual concepts of indexing, and also we will see selection of particular data and position labeling in data frames. So until then, I would like to give you guys an exercise to try out. Among the CSV files which I uploaded in the repository, pick any file and try the steps we did today. Okay, and come for any questions that you have. I will surely at my best knowledge try to answer those. If you have any questions, don't hesitate to ask in the comment section. I will feel more happier to answer. And as I have always said, please let me know if you want me to cover any specific concepts. Also, please subscribe my channel if you have not already done, and please like and share if you like my content. Please stay safe and stay healthy. Thank you.